like I said, this is what we've been doing, right? We've been simplifying expressions, okay? What we're going to do now is put an equal sign in here. And what was the answer to this on the homework? Secant?
Secant.
Now we're going to show that that is actually an identity.
Also like number
So,
17.
yeah, you're doing the same process of work. You're kind of given the answer. Okay. So it's the same process as before, but we're just going to make sure that this becomes secant theta. And so we can say that those are equal, and we have a trig identity.
Oh,
Okay. And we're gonna step into some harder problems. Some problems that are harder to simplify. Your same techniques will apply, but they're harder to simplify. Okay. We're gonna be foiling some trig functions and doing all sorts of stuff like that. So if we were to verify this as a trig identity, we would follow the same steps. Okay, your same, change it to sine and cosine, right? Again, works most of the time. I'm not going to say always, because I have had instances where it didn't. We're going to do some fraction math, right? And we're going to do some canceling with some more fraction math. Right, and then we know that's secant as well as secant. You have to get to the point where you have two equivalent statements. So this is our end game. So we've just verified that trig identity. Okay, very straightforward one. But again, no different work really than before. These get a little bit more challenging when we have stuff on both sides we have to simplify. Okay, that's the one thing we'll run across. I'll show you a couple, do some practice, and we'll practice the next few days. Today will be easier, tomorrow will get a little bit harder, and then we'll continue that through progress. Okay. Good? All right. Here's a little harder one. Verify that secant squared x minus tangent cotangent is tangent squared.
Wow.
Cheese whiz.
Not sure.
Got my cheese whiz, boy?
Not sure.
So verify that is an identity.
Is it one? Is it?
It says verify that it is, so it is. It's telling you, yes, it is one, you just need to prove it.
Ow.
Okay? This one gets, so what are your first thoughts?
Well, tangent times cotangent.
Okay, yeah, you've got an identity, reciprocal identity there, right? So if you notice that? So if you want to get really specific, you can do this. Those cancel out, right? And you have 1. So secant squared x minus 1 is tan squared. What's your next thought?
Turn tangent into cosine sine.
We could do that.
Can you subtract one? No. I'm not gonna.
Okay, is that what you want to do?
Well,
Change the sign to cosine?
Yes.
Okay, it's a good thought, so let's try it. What's secant?
is 1 over cosine.
Kind of messy. Okay, what are your next thoughts? So wait, do you want me to write down what steps I've done?
Yeah.
Like, okay, so this we used an identity. And then this from here to here we did change the sine and cosine. Which really is just using an identity. Right? It's just the one we use the most, so I separated it out.
There we go.
What next?
Well. Add one to
there we
the
go.
other side, or is that?
You could, doesn't get you anywhere.
So you swap.
So
So you add like 1 over cos square and add with sine square x. And here, I can show you.
Oh, can you
Yeah.
multiply?
Oh, yeah.
Paul.
I can do that. I don't know.
You want to
It's
move
like-
this over here?
Well, swap 1, -1, and the 1 on the right.
Oh, you want to move this over here?
Yes, and make 1.
Put that over there?
Yes.
Okay, so we're going to add 1, and we're going to subtract this. Okay, so basically what we're doing is we're putting the common denominators together.
That's,
It helps. The other thing you could do is make this cosine squared over cosine squared. That works too.
yeah,
but
that's what I was thinking.
either way, okay, so we have 1 over cosine squared x. I'm going to put that in black. And you're going to see that there are a dozen ways. Shut up, Richard. Okay. Black. Minus.
So
So
since
the last
it's
one,
equal-
so you move cos to the right here. To show you. So you like
You're right.
and multiply it up right here, right?
Yep.
So it's cos, and then when you add it, it's going to be 1. Because it's cos square and sine square. That's the identity.
So multiply by cosine squared. Those cancel. So we get 1 minus sine squared.
You add it.
It's
So.
cosine squared.
There we go.
That's true.
Yeah, that's actually an identity. You can do this and be done. What you want to do is one more step.
Oh, man.
Doesn't matter. Okay. What if I told you that was the medium hard way and there's an easier way?
Show us.
Yes.
Exactly. I demand you show me.
Show us.
Okay, I can eliminate. So, okay, so this is a perfectly valid solution method. Okay? But I can eliminate all of that.
Wow, please show us.
Okay? Is there an identity
Probably.
that relates secant and tangent?
Have you told us this?
Yep.
I don't know.
Yeah.
I gotta write
Yeah.
down.
There you go.
It'd be in your notes probably Thursday.
Well, it's not here. I did not take it.
Or it's 7.1
B?
under the Pythagorean identities.
Oh.
Secant squared equals 1 plus tan, or tan x plus 1, right? So I can put an identity in there.
Hey, what did you get then?
Secant squared.
Those are an identity, right? Pythagorean identity. What's plus 1 minus 1? What do I have? It's like Christmas morning, man. And I'm done.
So all you have to do is identify and try and find all the identities, and if you can.
There are a dozen ways to do these. It's okay to do the long way. That's fine. But there are shorter ways. Okay, so at this point, because I know the identities a little better, obviously, than you do, so I knew there was a secant tangent identity. Right, so I would look at that. Or you can go with, I know I can change the sine and cosine. And guess what? It's still going to work. It's a lot more work. It still works out. Okay. So these are two different solution methods to the same problem. You still get its verified identity. And honestly, when we got to this point, I gave you a third option here to change that 1 to cosine squared over cosine squared. Right? That's another option. Okay. Very much so, Kellen. So, does that make sense?
Yes.
You're still using, change the sine and cosine, we're still using identities, we're still using fraction mathematics. It's just a different way to tackle it. Okay. Again, this would be kind of a medium to medium hard problem. So, all right, let's look at one more. There are questions in your book that are kind of leading us toward our ultimate goal here. We're not going to go there. Okay. It will say find a numerical value of one trig function don't forget to put the fun in function. Don't bomb it. How many trig functions are there?
100.
I can count to 2. 1, 2, right?
Oh, that's what you meant. I thought you meant.
We need to get this statement to where there's only one of them. Okay, so just it's the same solution methods that we have had. Okay, so what do I do with that to simplify it?
Get it in terms of sine and cosine.
Okay, so cotangent is?
1 over 2.
Okay, that's not in terms of sine and cosine.
Oh, sorry, yeah, it's cosine and sine.
Okay, there we go.
That's going to be cos squared.
If you want to make it a fraction, you can. Okay. Next, not you.
No, wait, I have a question. Why is it cosine over 1?
Well, if you're doing fraction
Oh, that says
math, it just
cosine,
makes
but
it
I said
obvious.
changes. My bad, never mind, I got
Okay,
it.
good. Next,
You have to copy that.
yeah, you're fraction mathing again. You think you're going to be good at fraction math by the end of this one?
Probably.
Right. Boom, boom.
Wait,
1 over sine is? Cosecant. Easy enough. Is that one trig function? Yeah, you just answered the question. Okay. What we want to do, so this is kind of leading us to our ultimate goal, this unit, where we would actually find that value for x. Okay. So if I were solving this problem, I would actually leave it 1 over sine. Okay, so at this point, this is not what you're gonna have to do in the homework. I'm just giving you the clue to the future. I'm gonna multiply sine x on both sides to get 2 sine x.
Right.
Then I'm gonna divide by 2.
What half equals sine x?
Where is sine x, where is sine 1/2?
Oh, sine is 1/0.
No, it's not.
Never mind, I quit.
You're a quitter? That sucks.
Wait, 1/2 you said? Oh, wouldn't that be 90 degrees? No, 60. I don't know. I'm
He
just
tried.
guessing.
He gave a valiant effort.
30 degrees.
Well, you've given everything except 45.
Well, that's not it.
Yeah, it is.
It is.
Unit circle, where is sine 1/2?
2 over 2, 1/2.
Where is sine short?
Cos.
Short,
Yeah,
Paul.
yeah, that's it.
30 and 150.
Oh,
Oh, crikey.
Because I didn't specify a range. Again, pi over 6, 5 pi over 6.
yeah.
Okay. This is where we're headed, is being able to finish this off. Okay? You don't have to do it yet, but this is where we want to stop today. Feel free if you want to practice it. I don't care. Finish it. Okay. We use this skill in calculus as much as anything else, solving trig equations. Okay. Did you want me to write the steps down here?
No,
Now you're on.
Anybody? Yeah. Okay.
String.
That's all I've got.
can I take my unit circle test?
Let me make sure those aren't used. There's a lot of them. 5's not too shabby. 13, 14, 29. Yeah, those are all basic trig identities to solve. So we'll check it tomorrow.
Okay.
And then tomorrow we'll step it up a little bit.
Mr. Arthur, can I take my place?